Akash from there, because I think it's a design and verification conference. It's not a design verification conference alone for us, envisioned by Yatin and others who kind of chaired this for a long time. And I know there's a lot of PPA or performance area optimizations that Akash team is working on. Akash, go on.
Yes, yeah. Before I get to the PPA, I actually want to kind of talk about the theme that I'm hearing across this whole panel, which is that AI in its current state today is not very reliable, right? And what do chips need more than anything else? They need reliability, right? And so the question then becomes like, how do you deal with this problem of variability across models? How do you make it so that someone, a new engineer who's coming to the silicon space can actually design a chip with AI, but not be able to trust the output, right, and understand what's going on? And I think Shashank brought up a really great point, which is that there needs to be grounding in the EDA tools themselves, right? There needs to be some source of like silicon truth at the end of the day, right? That grounds what actually gets generated. And I think, generally speaking, when people are talking about generative AI for chip design, they're focusing on the generation part, right? But that's not really the only job of a designer. A designer is not just going and writing RTL and being like, here, Foundry, go take this, right? There's a lot of iteration that goes into it, right? Both in terms of the functional aspects and the PPA, right? And in the functional aspect, right, you need to write a test bench that has high coverage, right? And you need to make sure that you've closed all the possibilities of how this chip will get used, right? And then on the PPA side, you need to make sure that this chip is actually worth making, right? Not every chip is worth making, right? If it's worse than a processor that Intel or AMD or ARM provides, why would we make it, right? And so I think that there has not been enough focus on how can you use AI in the loop with tools. And that's, I think, a big problem that a lot of people are focused on generation. How can you fine-tune models to do this, fine-tune models to do that? Oh, how can I better prompt these? And I really think that it's more about how can we get it to use tools, and these tools may be based on open, built on top of open source tools, right? Because it's a great starting point for any startup to be able to develop new tools, right? But I think there hasn't really been enough of a focus, and I think that's where we've really tried to add our contribution here. And in terms of what we actually do, we basically build tools for AI agents to basically iterate on their designs, right? And what that means is we can give them actual feedback on, is this design actually good? Does it actually have the right power performance area characteristics that I'm interested in? And can I attribute that to a particular line of RTL that actually helps resolve an actual bottleneck in the design? And the same goes for verification, right? When you're fixing a design, you need to know which lines of RTL are actually the most relevant, right? And if you can provide that context to an agent, it can actually not hallucinate what the bug was or hallucinate how to fix it, right? And we've seen that this has for us improved our cycles with our customers. And then even more importantly, we've seen that if you fix something in PPA, it can break your functionality. And then if you fix something, if you fix a bug, it can completely, mess up all your critical paths, right? And so these two things, they have to be intertwined, right? You can't consider one and not the other, right? And so I think, I'm really hoping that overall the focus of, AI for EDA becomes how can we integrate the tools more closely with the models, right? How can we actually get these tools to, become, a co-pilot where they're actually, the tools are helping you build the product that you're trying to get to.
If